Yeah. Welcome to ORA 2022. Thank you for your contribution to our Congress. There are 8 presentations in this session. Your maximum duration 15 minutes. Also, all presentations are recorded. It will broadcast on YouTube after Congress. Is there any question about Congress? Okay. First presentation. Dear Obaid.
Hello,
Dear
everybody.
Professor. Hello.
Hello, everybody. My title name is Efficient WS and Routing Using Post-Straight PSO Clustering. My name is Ahmed Thara Waid. My prof is Mohammed Ilyas. Introduction. Then increasing convergence of microprocessors, wireless communication, and micro-electro-mechanical system has led to the development of wireless sensor network optimization problem for WSN, our usual version of classic problem in the operational research area, such as routing and clustering, which are NP default. Our contribution, our work contribution, our contribution are concluded as follows. First, we redesign the routing topology of the WSN according to PSO. Second, we modify the latch protocol. So instead of random choosing of the cluster heads, we choose according to PSO. We modify PSO algorithm with post-straping. We compare our words to the other words in the literature and in the term of QoS and expect sensor life. Our work in a few words. Our work is basically of a shame of dynamically changing the routing topology of WS and basis of the life remaining in each node. This is done by using the PSO algorithm to plan the path ahead of time and choosing the cluster head for the leech protocol. PSO and leech will work simultaneously together. This is first time such as work proposed. Post-rapid PSO. The possible solution are initialized by PSO as a population of particles associated with the random velocity. During the search phase, each particle keeps a track of its coordinates that correspond on the maximum fitness is had achieved so far. Another piece value, the global version of the particle swarm optimizer record is overall this value and its position as reached by any particle in the current population so far. The post-straight method, a statistical technique for estimating population value by a virgin estimates for several small data set. Conclusion. In this work, we represented a new scheme of dynamic reallocation of cluster heads and path planning using LH protocol and PSO algorithm. Our method to have better energy efficiency and low latency compared to both standard LH and optimized PSO. This work we has published in IEEE conversion, but we plan to expand this work with more scenarios and comparison with our real simulations on or to the Summit to Q1 general. Thank you.
Thank you for presentation.
Thank you.
Is there any question? Okay, next presentation, Ahmet Al-Zabak.
Yes, John.
You can start.
Yes. Can you see my screen?
Yeah.
So, hello, good afternoon, doctors and my friends. My name is Ahmed Zabak. I am a master's student for computer engineering, Karabuk University. First of all, I want to say thank you to everyone who organized and contributed to this conference. And my topic is artificial intelligence-based model for COVID-19 detection by analyzing X-ray image using CNN. This is my outline. I will through follow all of this, inshallah. Introduction. Coronavirus disease, COVID-19, is an infectious disease caused by newly discovered coronavirus. Most people infected with this COVID-19 virus will experience mild to moderate respiratory illness and recover without required special treatment. Older people and those with underlying medical problems like cardiovascular disease, diabetes, chronic respiratory disease, and cancer are more likely to develop serious illness. The computer-aided analysis of X-ray lead to gain in the processing, such as time cost and quality. We are dealing with this analysis lagged X-ray image and trying to classify them in the right manner with acceptable result. Problem statement. Before 2 years, the COVID-19 pandemic caused an increase in the number of X-ray required to detect COVID-19 in all healthcare facilities. This has led to increase in the number of doctors. Actually, when the doctors deal with this issue, compare with another issue. X-ray test offered in most of hospitals with low cost. This assists the countries in cost saving. Convolutional neural network, or CNN, are a category of neural network that have proven very effective in areas such as image recognition and classification. CNN have been successful in identifying face, object, and traffic signs, apart from powering vision in robot and self-driving car. So here we have the CNN function contained from convolution, linear ReLU, pooling, classification, fully connected layer. I will through for all of this. Convolution layer. Here we have in this figure, we saw the convolution layer. The picture is input here, and we will make the steps of CNN convolution, pooling, fully connected, and we'll get the output prediction. The main idea of convolution layer, it is to reduce the dimension of image, finding the features, and apply the filters. Here we have this pictures 5 by 5. We will change to 3 by 3 by filters 3 by 3. Move the filters around image, and we will get the convolute features. This is done by sums and multiply. Features map. The features map that the result from applying filters to input image, and features map output by a prior layer to could provide into the internal representation that the model has the special input at the given point in this model. We have this image, input image. Also, we have filters. Any filters have specific work about our image. For example, if you want to get the edge of image, you can apply edge detection. and so on. So activation function nonlinear ReLU. So for any kind of neural network to be powerful, it's need to contain nonlinear. Both the ANN and autoencoder we saw before achieved this by passing the weighted sums of its input through an through an activation function, and is not different. We again pass the ReLU of the result of the convolution operation through ReLU activation function. So the value and the final features map are not actually the sums, but the reduce, but the ReLU function applied to them. The main idea of nonlinear, it is reduce the amount of calculation. How it will be? We will keep the positive value in same value and change the negative value to 0. This is a condition to reduce the amount of calculation. The pooling steps. In the pooling steps, we have also types for pooling steps: max pooling, sum pooling, average pooling. But the common one is max pooling. So here in this figure, we have this figure 1. This obtained after convolution ReLU operation. We will make max pooling with 2x2 filters and stairs 2, and take the maximum value in each region. This reduces the dimension of our features map. Fully connected layer. After the convolution plus pooling layer, we added a couple of fully connected layers to warp up the CNN architecture. The fully connected layer applied to convert nonlinear features to the linear and one dimension. Output of the both convolution and pooling layer are 3D, but it is not accept 3D. It would fully connected accept just 1D. That is a review. Here we have some of several studies presented and analysis in this section show below. First one is the genetic algorithm and classify algorithm. In this paper, they propose a simple based transform learning methods to prediction the X-ray image and for detection COVID-19, and it's get 92.3 accuracy. Second one is CNN and BaseNet classifier. In this paper, use the contribution of the features extracted from multi-CNN with correlation-based features selected, CFS techniques, and BaseNet classifier for the prediction of COVID-19. And it's get 96.90 accuracy. Third one is capsule network. In this paper, display a new modeling framework based on capsule network for detection COVID-19, and it's get 95.7 accuracy. The last one is random forest. In this paper, they mix between hybridization of CNN and DWT features for detection COVID-19. Also, I have some literature review here, but I can't do for all of this because the time is limited. I move to our methods. The presented method consists from 23 layers. The input layers consist from 28 multiply 28 multiply 1 pixels, which wide and high consist from 28 pixels, and one represented the value of the each pixels that can be 1 or 0. And the second layer, 8 filters, 3x3 size, applied as convolution layer to extract the features and reduce input image size. The proposed structure consists from 5 image size. The presented structure consists from 5 convolution layers, which the size of filters remained 3x3 and the number of filters increased gradually. The normalization layer is the second important layer, is presented structure and located in the second layer and tracked by the ReLU activation function. In the 5 layer, the max pooling applied to reduce the size of input features and remove uninfected features and repeat it after each ReLU layer. Then the convolution and down sampling layer are tracking by one extra fully connected layer. And the last layer, it is fully connected, as I said, and also we'll get softmax to get the output. This is our data set. It's contained from 3 classes: COVID-19, normal, and pneumonia. It's contained from 6,432 images. I get it from google.com. Also, I try to get from hospital. We have 3 pictures: normal, COVID-19, and pneumonia. I get from dataset. Conclusion: the convolutional network is the main extractor features from these medical images and trying to reduce and extract the important features by collecting these features and make as an input to the classifier, which will make the prediction in the suitable way. We try to get the best result and high accuracy in the proposed method. So here some of reference, and thank you for attention.
Thank you for presentation. Is there any question? Thanks again. Next presentation. Dear Ahmet Muhis Santov. Dear Shantov or Santov? Not online. Dear Reem Abbas. Dear Abbas.
Yes. Rawa Kazim, the co-author.
Dear Rawa Kadim. Dear Kadim. Okay. We continue next presentation. Dear Milevski.
Hello, I'm ready. Nice to see you. Now I will show you my presentation.
Okay, you can start.
Dear Congress participants, I am Milevski Stanislav, Associate Professor of Cybersecurity Department of the National Technical University, Kharkiv Polytechnic Institute. In this report, I want to present the results of research on the topic Social Cyber Physical System Security Concept. The development of high technologies and the rapid growth of computing systems have made it possible to rapidly develop mobile technologies and make prerequisites for the integration of Internet of Things and mobile technologies. The emergence of new directions, Smart City provides further digitalization and expansion of the range of services. So-called cyber-physical systems are being formed that ensure the integration of computer, Internet of Things with social networks and mobile technologies. However, on the other hand, such development trends form a new vector of threats in cyberspace, which requires protection not only of the physical structure of social cyber-physical systems, but also the need to protect to control systems, which are usually located in the cloud. There is an objective need to form multi-counter security systems that take into account the synergy and hybridity of modern threats in three security components: cybersecurity, information security, and security of information. This slide presents an analysis of modern wireless technologies taking into account the provision of security services. As a rule, symmetric and asymmetric crypto systems are used to provide security services. However, unfortunately, in the post-quantum period, the appearance of a full-scale quantum computer, the stability of such systems, according to experts of NIST USA, is called into question. To ensure security in mesh sensor networks of cyber-physical systems with elements of the Internet of Things, the mechanism of the KNX standard are used. The main approaches are presented on the slide. AES encryption is used as the main security mechanisms. However, the control system itself in the technology of the smart home system is based on the cloud technologies, which doesn't provide an opportunity for an objective assessment of the level of security in the system as a whole. It is believed that everything is secure and free of threats in the cloud, but it is far from this case. And the results of 2021 show that 43% of cloud technologies do not provide the required level of security and are susceptible to threats. So it becomes necessary to consider not only the classification of threats, both in the internal and external contours of threat, but also the formation of a multi-counter security system based on a set of threat models for all components of security. This approach provides the ability to form an objective threat assessment and accordingly allows to build a stable protection system. This slide shows the proposed classifier of threats, which is intuitively understandable to the average person and takes into account not only the synergy and hybridity of modern threats, but also allows to identify critical points in the infrastructure of social cyber-physical system. This slide presents a structural logical diagram of a multi-counter security system, which allows to take into account the totality of threats to the components of security, both in the internal counter and the external security counter. In addition, this concept that we propose to use post-quantum algorithms as the crypto code constructions of McEllis and Niederreiter, while taking into account the level of secrecy, we propose to use various codes for constructing data of a symmetric crypto system. The latter are just used in wireless internet technologies. This makes it possible to use these protocols at no additional cost. This slide also presents the decoding algorithm, which allows to reduce the error level when decoding the PDLC code word. The main elements are three components: a key generation server, a software application, and a chipset with a programmable encoder. The practical implementation of the proposed protection mechanisms is implemented to close the voice internet channel of mobile communication and allows real-time provision of a confidentiality service. At the same time, this approach allows to close any communication channel and provides the level of security required to the post-quantum crypto period. This approach, which proposed to be used in the smart home system, however, in addition to the three components of the security system, proposed to use its own control server, which allows to close the communication channels between the sensors and the control server. And there is no need to create a security system based on cloud technologies. This ensures single continuity and accordingly a higher level of security for the system as a whole. The results of using the proposed solutions provide security in the post-quantum period, reduce the cost of providing security services, and allow integration into a smart city, mesh and sensor network technologies. At the same time, the basis in the post-quantum encryption algorithms, the cryptocode systems of McEllis and Niederreiter on codes that provide resistance to modern threats. So this is it, and thank you for attention.
Thank you for presentation. Is there any question? Dear Kadim? Rava Kadim, dear. Okay, next presentation. Dear Serten. Serten. Not online. Dear Yasin.
Hello, Hajan.
What's paper ID?
Unsupervised. It's on behalf of my supervisor, Serten, Dr. Serten.
Okay. You can start.
Mhm. Hello, everybody. I'm Siraj Akela. I'm a PhD student in Nearest University in North Cyprus, Biomedical Engineering Department. Today is my presentation is about unsupervised classification of COVID-19 using chest X-rays with convolutional autoencoder. This is the outlines for the presentations. As an introduction, first of all, COVID-19 is highly infectious diseases. The virus known to be responsible for disease is referred as a severe acute respiratory system coronavirus 2, the second generation. Considering the novelty of this disease, when the first globally appeared in the early 2020, several lives were lost as the world was unprepared and tackled the pandemic of this scale. One of the first success recorded in imaging and saving the lives of people infected with COVID-19 came when experts realized that the early diagnosis and the subsequent intensive treatment can significantly reduce the mortality rates. And interestingly, unlike many other diseases with a clearly defined symptoms, the COVID-19 can present many different symptoms and thus make it considerably difficult for doctors to quickly and easily diagnose. So some symptoms of COVID-19 include breathing difficulties, loss of smelling and tasting abilities, headaches, body aches, cough, fever, and even diarrhea. Meanwhile, it's well known that several people who are infected with COVID-19 don't present noticeable symptoms. This observation was followed by the urgency to produce the different, accurate, fast, and minimally invasive diagnosis methods for COVID-19. These attempts have reduced the various testing approaches, such as polymer chain reaction, which is PCR, which use body fluids such as swabs collecting from the nasal and back cavity and regions. Sorry?
Slide does not change.
Yes, it's this is the medical introduction about the disease. Then we'll continue for this slides. I'm gonna take.
Slide
this-
does not change. Next slide.
Yeah,
Next slide.
we're still in the same slide. Yes, this one. Yeah. Let me just skip. Generally, the diagnosis for COVID-19 with chest X-ray requires an expert for evaluation and determine if the patient is infected or not. Given this is the huge number of chest X-rays that have no to be evaluated. This process can become tedious and erroneous. There's a loss of errors, I mean, diagnosis due to the human fatigue. As alternative machine learning models can be explored for automatic classification of chest X-rays for COVID-19. These machine learning models are generally supervised classifiers in the labeled data and has to be collected in order to train them. Unfortunately, the collection of labeled data set for COVID-19 can be challenging due to the huge cost and long processing times and limited human resources. In the view of this problem, this paper proposes the unsupervised classification of COVID-19 using the unlabeled dataset containing cases with and without COVID-19. We propose to apply convolutional autoencoder for classifying the chest X-rays. First, we clarify that in this paper. I'm going to check the, yes. Oh, sorry. Our contribution in this paper to propose unsupervised classification of COVID-19 using chest X-rays with the convolutional autoencoder, perform several experiments using publicly available dataset to show the effectiveness of the proposed classification model based on the performance metrics such as accuracy, recall, precision, and F1 score. Finally, it's shown that the proposed model is faster than the several state of the art methods during the testing. As such, many more diagnoses can be completed in a shorter period using the proposed model. This is the proposed classification model. We have a convolutional autoencoder and convolutional denoising autoencoder and convolutional dropout autoencoder. In this section, presents the proposed machine learning model for classifying COVID-19 using the chest X-rays. The machine learning model is a combination of convolutional neural networks and autoencoder, which is referred as a convolutional autoencoder. And the simplistic term, the convolutional autoencoder is CNN, that's a convolutional neural network that operates like an autoencoder in that it can learn the reconstruction and the reconstruction of the input data in the output layer of the model using compressed representation in the hidden layers. To improve performance of the model, denoising and dropout training criteria are applied, and to obtain the additional models that we are referred as a convolutional denoising autoencoder and the convolutional dropout autoencoder. In the rest of this section, the different convolutional autoencoders are discussed based on the how regularization and the hidden representation are achieved. The convolutional autoencoder is the typical autoencoder without an explicit regularization on the learned representation, while the convolutional denoising autoencoder, the convolutional denoising autoencoder aims to regularize the hidden representation of the model by tasking the model reconstruct corrupted input data in the output layer of the model. This is expected to increase the robustness of the model and to small contribution in the input data. While the convolutional dropout autoencoder aims to regularize the hidden representation of the model by randomly using the subset of the hidden units to reconstruct the input data in the output layer of the model. In simple terms, this can be seen as randomly masking a subset for the hidden layers unit. The expectation is that will break the coadaptation of hidden units for learning, so the model is robust to small variations in input data. This is the proposed classification model, and we have got the data set. The data set we have used in this study, the data set used for validating the proposed models for classifying the chest X-ray for COVID-19 is the Corona Hack Chest X-ray dataset. In the original dataset, we select only negative healthy samples and samples with COVID-19 for more training and validation. The statics of the collected dataset are given in this table. It's a small data. We have got negative chest X-rays, which is 1,576 image, and the positive it's only 58, while the total is 1,634. So in this experiment, the different convolutional neural networks as convolutional autoencoder
Serap,
and the sorry.
Slide not change.
Yes, I changed it from the data set to this one, the experimental setting.
Your presentation only first slide.
On the first slide,
You can continue.
now which slide is appears in this?
We are only seeing the first slides.
Even now?
No.
Sorry. Maybe there is error. I don't know what the problem is.
Yeah.
Now it's okay?
Yeah. No problem.
Okay. So in our study, we are designed for this model for diagnosis of COVID-19, and all models have two layers. All models have two layers for the encoder, and two layers for the decoder. And the first and second layers in the encoder have 16 and 32 convolutional filters, respectively. While the first and second layers of the decoder have 32 and 16 transpose convolutional filters, respectively. These models are trained to using the only chest X-ray samples from the negative class. And the model used rectified linear units in the hidden layers, the linear unit in the output layers. So here for this, the metrics that used for evaluating the performance of different models are the accuracy and recall, precision, and the F1 score. To see the result of this study, the result of our experiments based on the problem or the performance metric are shown in table 2. In table 2, and in table 2 to 5. This is the table 2 and 3 and 4. This is table 5. Here we can notice it will be seen that the supervised and the pre-trained ResNet 34 gives the best results, while the proposed model that are unsupervised provide very competitive results. And it's observed that the proposed convolutional denoising autoencoder provided the best testing performance in comparison to the convolutional autoencoder and the convolutional denoising autoencoder. From table 2 to 5, in fact, the proposed model outperforms other supervised models in table 2 to 5. The proposed model don't require any kind of pre-training as some of the other models, which is importantly shows that the proposed models can be employed where the available dataset for model training is unlabeled. From table 6, we can see the VGG 16 and ResNet 34 have highest latencies for testing, but this is not surprising since they are largest model in comparison to the other models. But however, the proposed models, the convolutional autoencoder and the convolutional denoising autoencoder and the convolutional dropout autoencoder have the smallest testing times, since they use far fewer model parameters in comparison to others. In conclusion, the medical diagnosis has, in recent times, enjoyed the attention from the machine learning community in this paper. And we address the problem diagnosis COVID-19 using chest X-rays in the case where the labeled dataset is unavailable. The solution of proposed is using unsupervised convolutional autoencoder with various regularization methods such as imposing and denoising criterion, or applying the dropout of hidden units during the training of to improve the generalization performance. Using five-fold cross validation scheme, we show that the proposed models outperform many state-of-the-art models, including those trained using labeled dataset. In addition, the proposed models are several folds smaller than the state-of-the-art models, and therefore have considerably smaller latency for interference. These attributes allow the more diagnosis to be completed in a shorter time as compared to the other models. As such, the proposed models can find application in practice. Thank you for attention for all.
Okay, next presentation, Rawa Kadim. Dear Kadim. You
No.
can share screen.
Is it our turn?
Sorry.
Research for 190?
You can share screen. Dear Kadim. Is your presentation ready? Okay, next presentation, dear Yasin.
Are you mentioning Sharifah Nurul Hikmah? Said Yasin?
Yeah,
Okay.
Sharif Nur Hikmak Yasin. Yeah.
Yeah, okay, it's my name. Oh, somebody is presenting, I think.
You can open your presentation.
Okay, let me present first, eh? But the other participant are presenting, are sharing their phone. The other participant is presenting right now, sir. So I cannot. I can't
sorry.
present my. I can't present my screen now.
You can change screen.
I'm trying to share my screen, but somebody is presenting right now, so I cannot share my presentation. Let me see who are presenting. Rawa Kadim is presenting her phone right now. So I cannot present while she is presenting. Okay. Now she's turning off, right? Okay, can you see my screen, sir?
Yeah, no problem.
All right, thank you. So thank you so much, Mr. Chairman. Assalamualaikum and hi. My name is Sharifah Nurul Hikmah. I am from Malaysia. And today I'm going to present our paper, our research paper entitled Mobile Educational Game User Experience Element, a Systematic Literature Review. Okay, so I will divide this presentation into 4 sections: introduction, methodology, result and discussion, and lastly, conclusion. Okay, so let's discuss the introduction first. mobile platform with smart features encourage users to connect and interact with people from all over the world. And this mobile technology allows the user to explore more and more over the mobile phones, including to do the social interaction, conducting the business transaction, playing games on, and also to learn. Based on the recent statistics of general or entertainment-based computer and mobile game, the trend shows that the number of users has significantly increased from year 2015, where it had 2 billion gamers on that time, to 2021 to nearly 3 billion of gamers. And it is expected to create more than 3 billion gamers in 2023. And these statistics shows that mobile devices have been a significant technology in the daily lives of teenagers, kids, and also the children for entertainment. So it shows that the acceptance of mobile technologies and evolution of mobile game offers the opportunities to revolutionize the education by blending the mobile learning and game learning methodologies. In fact, the COVID-19 pandemic has accelerated the research, design, and implementation of mobile education. So mobile education or mobile serious game, educational game or serious game, I created to achieve specific effects, goals, skills, and also the specific behaviors. Therefore, the evaluation framework is needed to assess and remove the flaws and increase the efficiency of the mobile educational game. And the evaluation of the game involve many complex criteria and features. Okay, for example, the nature of the subject or lesson, the pedagogy, the content, motivation, skill uplifting, and behavior change. So it is very important that the educational games designers, developers, and the academicians to identify the legitimate components in the modeling, user experience evaluation framework that could assist them to produce the compelling and practical educational game design. So next section is the methodology. In order to conduct the systematic literature review, we applied the SLR or Systematic Literature Review framework from Kitchenham et al. 2009 that has 3 phases of tasks to be completed. So our SLR examined this research question. What are the existing UX elements for evaluating the mobile educational games? Okay, so this is the research question. And based on the mentioned research question, the keywords are identified. So the keywords are mobile, educational game, user experience, and evaluation. And these keywords are well defined, and we have identified the synonym words of each of the word as well. So we also use the synonym word in the keyword. Okay, the resources of this SLR are from IEEE, Springer, Science Direct, Emerald, and others databases that are related, including the Google Scholars. And all research papers have gone through double layer inclusion and exclusion criteria filters as listed in the table. And we only review the paper that has the inclusion criteria. That is any studies with any of the mentioned keyword, studies in English or Malay, language, studies with full text papers only, and review papers. And we also accept review papers and also the research papers. Okay, in data extraction phase, we look for listed points from each of the papers in order to answer the research question. So the points are the UX framework. Okay, so the UX framework, the dimensions or the element of the UX, and also we look for the evaluation question or the sub-element for each of the element mentioned in the research. Okay, by using the identified keyword, a number of 280 research articles or papers are listed from all of the databases, and 34 has been selected to be reviewed based on the inclusion and exclusion criteria. To assess the quality of the evidence reported by the selected studies, we have applied the quality assessment checklist also by Kitchener. And the scores of the quality assessment are calculated by using this formula. Okay, now let's discuss the result of this SLR. All of the studies included in this SLR receive a score of 4.5 or higher out of the possible total score of 9, which is the rate of 50% quality. And from the review, we have found that there are small amount of literature that discuss the mobile platform for educational game. Okay, in addition, most of the mobile educational game study found have implemented the augmented reality or AR as the main technology in their games. Hence, the reviewed studies include the studies that are not or non-mobile platform educational game. Okay, we have to include the non-mobile research as well. The main reason of including these types of study is due to the UX element that they have mentioned in the study, in the non-mobile studies, are possible to be implemented in mobile educational game evaluation as well. So that is why we also include the non-mobile literature. And 23 of 34 papers that we have reviewed are the non-mobile researches or papers. Okay, so this SLR has found that not all mobile educational game evaluation have included mobility, okay, as the evaluation element, and there are various combination of element in executing the evaluation. So the most used evaluation, UX evaluation element are learning, and then a second is usability, and then followed by the immersion, and then the challenge, and also the feedback of the game. So as the conclusion, we have thoroughly reviewed 34 studies or articles from 280 identified articles, okay, and then all of the studies have been evaluated by using the quality assessment scores, where all of them gain more than 50% scores, meaning that we the studies that we reviewed have the good quality. Okay, and then from the SLR process, we found that most used UX element in evaluating mobile educational games are learning, usability, immersion, and challenge. And the mobility element has been ignored in several educational game evaluation, and this point where the mobility has been ignored in mobile educational game evaluation have to be thoroughly studied in the future. So I think that is all from me. Thank you so much for your attention.
Thank you for presentation. Is there any question? Okay, next presentation. Dear Al Abbasi. Dear Abbasi. We are not hear your voice or speech. You can change microphone.
Hello.
Yeah.
Okay, I'm ready.
Okay, you can share screen.
Okay. Hello, everybody. My title resource allocation in cloud file system using genetic algorithm. My name is Sohaib Nasir Latif Al Abbasi. My ID 18, Professor Dr. Garib Transceiver. Background cloud computing systems are badly evolving toward multi-cloud architecture supported on heterogeneous hardware. Cloud service providers are widely offering different types of storage infrastructure and multi-node architecture service. We live in an ever growing digital world with an increasing reliance on data. My problem accessing cloud resource allocation solution do not comprehensively consider this heterogeneous infrastructure. However, these approaches exclude some cloud storage type and shared memory patterns of application which are manifold consideration for efficient resource allocation. There is a need for a comprehensive approach to take advantage of this increasingly available infrastructure. Materials and methods for computing genetic algorithm. Now for computing is a new conventional paradigm that emerged from the need to reduce network usage and latency in the Internet of Things, IoT. What can be considered as a continuum between the cloud layer and IoT user that allows the extraction of application or storage processing of data and network infrastructure device. Genetic algorithm is one of the most popular optimization techniques. It is a meta-heuristic inspired by natural selection. The optimized of genetic algorithm is based on successive generation that combine crossover operator, the best solution selection operator, and fitness to create new solution. Random changes. Mutation operators are also considered to avoid local optimization. Genetic algorithm is classified into a group of evaluation algorithm. Proposed method. How resource allocation work and resource. How resource allocation work, resource optimization techniques and fog computing are examined and analyzed with special emphasis on genetic algorithm as characteristics and design alternatives. When the fog resources are requested by numerous task proficient task scheduling, the procedure is specifically significant. Workflow scheduling and fog computing assign of every task to a parent fog service by gathering the implementation of several resources to attain suitable QoS. This resource allocation work, cloud fog, hardware resource height and fog limited, hardware future homogeneous heterogeneous fog, location in cloud limited and generalized static nodes, and on fog geographical distributed static and mobile modes. Network future homogeneous high speed low latency, and fog heterogeneous cases of high latency, scale number of nodes 1,000 and fog millions. Result, we assume that a code allocator should promote better use of resource and extraction time that does not compromise the performance of the system whole. In order to promote reliable analysis of the genetic algorithm, we will make several changes in some of its parameter, either input or control. This figure cloud and fog. Conclusion, we proposed the use of genetic intelligence and fog nodes in order to achieve the optimal path to the cloud and back. The provision of resource need to be seen in several layers, where each layer represents a specific genre of resource that can be provided in different ways. This proposal is extremely challenging because it represents a major paradigm break. Science until very recently convinced and inviters use exclusively the computer resource in a proprietary way. Thank you.
Thank you for presentation. Is there any question?
Thank you, Doctor.
Okay, thanks again. Dear Kadim?
Well, excuse me, Rawa had some issue with Annette, so I will present instead of her. Reem Jamal.
Okay, you can presentation.
Yes. So our research is ARPA passenger gate checking up system for infection with COVID-19. The research issue is COVID-19 virus has a high contagious infection capability. Airports help in eliminating the danger of infection by preventing the virus to be spread for far distance among countries, of course. A check-up system for passengers coming to the airports is a very important protective step. People check up for temperature and more than 2 other risk factors that might indicate the infection, calculating the probability of infection according to the positive risk factors, and this is between the passengers who came from the same country. The objective of this research is building a control system with sensors, Arduino and an LCD as a final stage, feedback of these data to the main server, calculating the probability of infection according to passenger reading, isolating of people with very high probability of infection, in a place and people with low probability of infection in another place. The methodology. The system can be divided into 3 stages. Stage 1, checking temperature using temperature sensor, kind MLX 90614. Stage 2, LCD question. The question will be presented in LCD to check if the people have positive infection or not, like all the risk factor which can cause this infection. Stage 3, isolating room. We had 2 rooms, 1 and 2. The room 1 is with the people who had infection with a positive, and the room 2, which they have only temperature rise. So our block diagram of control system is this. We have a server and control system, which have the Arduino, which control several motors to open the door when the passenger is answer yes or no about the question that be in LCD. The passenger who have only temperature, will isolate him in room 1. When he said the sensor temperature will check its temperature, his temperature, sorry. So if his temperature is above 37, so he will go to room 1 by opening the door by control system, which run the motor 1. So if he has only temperature, he will go to room 1. If he has more than symptoms than temperature, he will ask on some question that appear in LCD. So if he has 2 or more symptoms, he will go to room 2 by opening this room by the Arduino, which control the door 2, the motor 2. Motor 3 will be open if he has no temperature and no other symptoms. So this is the block diagram of the control system. The program, we program it by the Arduino language. So this is our the flow chart of the program. As I said before, if he has only temperature, room 1 will be open. If he has no temperature, room 3 will be open. If he has temperature and other symptoms, room 3 will be open. And after the check system, we will make a probability that other passenger in the same airplane is infected or no. For S equal 1, this S means the symptoms, number of symptoms that is here. So A means number of factors, A probability of infection, and N number of people that we discovered that they had some symptoms. So we calculated the probability as equation. If he had some infection, so the success factor is P1. If he had no infection, so the unsuccess factor is 1 minus P of A. So we take some passengers and make research on them. The result was as shown. In blue is the number of cases, the positive cases, of course. In red, it's the number of negative cases that has no symptoms. The green one is the infection probability. He is infected or uninfected. So this is of the probability and positive symptoms. We see that we make a probability. So when we have symptoms for between passenger, when we make a probability is the number of probability that come into the infections or no between passenger. This will send to their country to announce them that they had a lot of passengers who have infection with COVID-19. As a conclusion to our research, the department has been linked to perform checkup for travelers. Simple and available tools were used. We used some Arduino, which is simple, and other motors. So the design, all the design was simple and very effective. So and we had low cost in this design, and we get high efficiency. Besides, we calculate the probability, and this will lead to reduce the infection between people in airports, especially and in the world in the future. Thank you.
Thanks for your presentation.
Thank you.
Is there any question? Okay, all presentation are completed. Thank you for your contribution. Is there any question about Congress?
Yes, sir.
Okay. Yeah.
Can I ask one question, sir?
Yeah.
So I was supposed to present in another session, but I was not able to find the link. Is it possible if I present in this session, sir?
You can send by email.
Okay. What should I send to the email, sir?
In today?
No, it was yesterday. Paper 114.
Okay, okay, no problem.
Okay. Can I present here, sir?
What's paper ID?
Paper 114.
114.
Yes.
1 second.
Okay, sir.
Titled the Internet of Things.
Yes.
Domains. Yeah. Okay.
Yes,
okay.
sir.
You can presentation.
Okay.
No
Thank you,
problem.
sir. Thank you, sir. I'm sharing my screen, sir.
Yeah.
Okay. Thank you, sir. So my presentation is about the Internet of Things, a domain-specific requirement classification. What's in it? We have an abstract, the introduction, a literature review, methodology, architecture and threats and attacks, the classification and the conclusion. For the abstract, worldwide, societies are rapidly becoming more connected owing to the growing number of smart things and smart applications like the smart automobiles and the smart wearable devices. All of this is all because of the Internet of Things concept, whereby the things in the physical world are connected to the virtual world. It's promising, but the IoT systems being deployed in a large scale brings with it security concerns. Hence, the need to allocate appropriate protection for all the resources. The paradigm likes a proper and exhaustive classification of security requirements. That's why our paper presents an approach towards understanding and classifying the security requirements of IoT devices for designing cost-efficient and purposely secured future IoT systems. During the coming up with the classification of the security requirements, we presented a variety of setups and defined possible attacks and threats within the scope of IoT, considering the nature of IoT and the security weaknesses as manifestations of the unrealized security requirements. For the introduction, the Internet of Things have rapidly been advancing all over the societies and enormously improving the way we live. It promises a rise in the connectivity and the efficiency, hence an improved productivity and decreased required effort to do plenty of things in our modern life. In the literature review, we came across a lot of work, but to this aim, we focused our discussion on the contribution that we can extend and complement the literature that is in this field. The novel heterogeneity and complexity of IoT systems include a wide and unexplored attack surface. These attacks can result in grave consequences to individuals and organizations in the long run. The methodology used in our paper is like, the main aim of this particular section is to discuss the methodology adopted in this paper to classify the security requirements. Firstly, the used architecture is described. Then we tackle the IoT threats and attacks that are put forward in an orderly manner. Then we explain how our classification is organized. First, the IoT security architecture. Several IoT security architectures have been put forward throughout the literature. Most of the works suggested three-layered architectures comprised of application, network, and perception layers, even though very few, there are some that proposed a four-layered structure. Nonetheless, there is no universal structure design for IoT that is being widely used as the recommended standard for the security architecture for any IoT. After analyzing several works, we use the 5-layered security architecture, which is depicted here in the diagram. That is, we have the device sensing layer, which has actuators, smart sensors, and RFIDs, which are used for the sensing of the data. Then for the next layer, we have the network management layer. That one has the wireless and networks and the big data storages, which is used for the quality of service and aggregating of the data. Then for the next layer in the IoT, we have the middleware technology like data analysis and data handling. Then we have the layer for the applications like smart transportation, smart health. Then after that, we have the user layer. In the user layer, it's all about enabling the users to access services. What are the threats and attacks that are seen towards IoT? In this next section, we kind of examine the possible attacks and threats that are done to IoT. Most are in conjunction with the numerous IoT application settings. We drive an approach to grouping them into 4 categories. As you can see here, we divided the categories into the communication, that is the attacks that and threats through the wireless and wireless channels. Then we had the devices, those are attacks that are directed towards the physical IoT devices, like the battery exhaustion. Then we have the users, which includes the attacks and threats on the people in the IoT systems. Then we have the mobility, which has attacks and threats that take advantage of the mobility of the IoT. Then here we talk about the classification structure that we use to classify the security requirements of IoT, which is showed here in the diagram. The possible threats and attacks at each layer are included in the classification. And then we also put the topmost requirements security-wise for an IoT system in a specific domain, as you can see in the diagram here. First, we have the application domain, the IoT layer, and then the attacks and the security concerns on that specific layer. And then in general, which security requirements are supposed to be taken care of in some application domain. That's specifically how our classification is structured. The security requirements we're talking about. Here are a couple of the security requirements: access control, confidentiality, authorization. Most of the works we came across presented analysis of IoT security, which needs architecture as an extra. So we tried to classify the security requirements specifically in our work, which we weren't able to see in anywhere in the literature that we came across. The first 10 are the usual ones that can also be seen in other application sectors besides IoT. Like, for example, authorization, confidentiality. We can see these security details in other sectors, but the others are just connected to IoT. We kind of constrained and squeezed all these security requirements into a more concise manner, and then we gave a brief description. For example, one of the security requirements that we propose is end-to-end security. This is supporting the end-to-end security when communication path traverses the multiple domain. Then we have the management of identities. We have lightweight solutions, that is solutions just for IoT because of its constrained nature. Then we have the decentralized management, scalability, that is supporting huge volumes of applications, data and support and services plus users, robustness, privacy, mobility, heterogeneity, and also the transiency. When we come to our classification, we try to tackle a few of the application domains. To be specific, healthcare. There are different application domains of IoT. We have aviation, we have the automotive, smart buildings, smart healthcare, smart transport systems, smart supply chain, smart manufacturing, smart grid, and smart farming, and so on. To give an example of how our classification can be implemented, we chose smart healthcare, which is popular for using IoT. For example, the elderly can be monitored from their homes by just using NFC or Zigbee or Bluetooth activated devices. Here is a classification that we gave an example. For example, in the smart healthcare IoTs, any IoT that is used in the smart healthcare, of course, it will have a device sensing layer, a network layer, service composition layer, an application layer, and the user interface layer. In the device sensing layer, there are security concerns. The main security concerns that we came across throughout the literature are authentication, authorization, and access control. Then we have the security attacks that are prone to this specific layer, the devices. We have physical attacks to the devices themselves. Then for the network layer, we have the passive attacks, flooding. Then for the user interface layer, we have trust, location privacy, data confidentiality. For example, if the data, let me say, the IoT is used for measuring the heartbeat of a person, we have, is the data collected confidential? Can other people access it? And so on. Then we have IoT specific requirements that can be met in the smart healthcare sector. Then in general, throughout the literature, we came to the conclusion that for any IoT that is used in the smart healthcare domain, they should be more careful about the authentication, the confidentiality, the integrity, and the privacy. All in a nutshell, our study, the classification is done from an expensive perspective, considering the domain in which the IoT has been applied. It should be noted that the requirements we have classified are proposed and not mandatory for all IoT systems, and not all IoT nodes must comply with the most stringent security requirements. However, if taken into account, one can provide just the required level of security, as application-specific requirements might vary. This might be extended by adding even a more comprehensive analysis to include even other domains that we mentioned about. Thank you for listening.
Thank you for presentation.
Thank you, sir.
Is there any question?
No,
Okay.
Thank you. Thank you, sir.
Thanks to all participants for your contribution. Is there any question about Congress? Okay. See you. This session is completed. Thanks again.